Welcome back. I'm sure you enjoyed that 5 minutes break to stretch and do and have a cup of water or whatever that interested you. And yeah, welcome back. And let's move on to what's out there for the rest of the day. Some applications of embedded system design where it is used, and there is a lot of other areas where embedded system applications are used. Being electronics, as you can imagine, everything that you are using on a daily basis, that's one way or other related to an embedded system. So the main categories of the applications where you would see embedded systems are those following: aerospace industry, the automotive infotainment, your smart home, industry 4.0 automation, that is the future growth industry, robotics, communication, yes, with GPS, sat nav, and all those audio video applications with DSP applications, and medical imaging, yes, with all the scans, excuse me, CR, excuse me, sorry, like MRI, CT scans, all those, and also some other applications, some other areas where embedded systems is widely used. But these are the main industries where they do a lot of real good projects and help a lot of people using those developed products into this industry. Next, we're going to learn how to create a prototype. So you are coming up with an idea, like you have something on your mind that you want to develop further and bring that into a usable product. And these are all the steps you have to follow. How to convert an idea to a prototype. So something that comes in your mind and how you would be able to see into that simple board like that. These are all the steps you have to follow. Choose the right processor. So as a design engineer, you get the first responsibility to if you're a junior engineer, then the senior engineers will come to you and they will give you all the customer requirements, what the customer wants from the project. And as a junior engineer, you have to sit with your time, and you need to do a lot of feasibility studies and research and come up with the right processor and to discuss with your senior engineers and then choose the processor. Then collectively you have to choose the development tool, what software tools and what hardware tool you're going to use to develop your system. And again, you have to deal with your senior engineers, or if you are in a small team, if you want to do by yourself, then you need to talk with your customer clients and then decide which one you're going to choose. But again, being a design engineer, it's your responsibility to choose those two as the main before you jump into the real project itself. Then the third one is to, does the application needs an RTOS, a real-time operating system, or just a simple program where it can be run with a simple infinite loop if it's for small applications, or it does have an RTOS. You need to decide that. And then choose your packages and production tool. What sort of packages your chip, for instance, is it a through hole or SMD, or can it be a ball grid array? And then the production tool that's going to go with, like ball grid array chip microcontroller needs a assembly unit to assemble that. It's hard to do it on hand, so that adds to the cost. So you need to be aware of the cost and the packages with the project that you can handle. Then once you collect all of that, you have to bring all of that into a software, a tool where everyone can follow that, and this is where the conversion starts to happen. So whatever you created so far, you learn all the design drawings that you written, everything, or scribble whatever the senior engineer has given to you. You have to choose a schematic design. And again, there are plenty of tools out there. For example, Cadence Arcade, Altium Designer, which is so popular here in Australia, and there is Mentor graphics pads, and there is Eagle, KiCad. These are some of the tools which will help you to do that job. So bring those written or scribbled design circuits into schematic design. Schematic design is about drawing circuits in there. And while you do that, consider for design for testing and design for manufacturability that you will learn when you do that. And then once the schematic design is done, you have to convert that to a layout design. Layout design is where you're going to learn to do how to route the connections from one pin of one device or chip to the other connector, if you like. So that needs particular skill, and you will learn that in the layout design. And that's again one of a major division by itself. There are a lot of engineers who does only schematic design and layout design, which is classified under the PCB design engineers. Then after that is your assembling, debugging, and testing. So after you written your code, you did your hardware design, then you come up with a sample test product, then you fire that code into that product, and then you start to debug and do the testing, and then you check for the functional coverage according to your customer requirements. Then for safety, you need to start to design an enclosure to keep everything intact in one enclosure. So for safety, again, you need to design that. And again, there will be other departments of engineers. You have to form a relationship with them and come up with the enclosure design that's suitable for that client. And then if you're going to market that your product to other countries, then definitely you should go for a certification. And CE is one of the world range certification that they give approval for your design. So you can build the prototype and you can start selling. And if you're doing a mass production of your design, then you have to, as a design engineer, you need to design your test jigs for mass production so that you can test about thousands and hundreds of thousands of products at one single time. So these are all the things that you have to follow to convert the ideas from the ideas to bring that board for everyone to use. So if you follow that, then keep a checklist for everything. I'm sure you won't go wrong anywhere. And these are all the steps that you have to follow. Okay, let's get into learning about the important topic in the embedded system design. Yes, it is about embedded development lifecycle. This is the whole development lifecycle. So I know it is a lot in there in the slide, but it's all simple and easy once you start your career and go through section or department after department, and then you will by end of 20 years like me, you'll have the whole knowledge in your head, and you would be able to converse it to anyone. But I'm sure with these latest trends, you would learn much faster than I or what I my approach was. So let's learn about the embedded development lifecycle. As you know from the definition, embedded system design has both combination of hardware and software with some associated mechanical parts. And this is what the development lifecycle is involved. It has got both software and the hardware. Let's start off with the software side. First, you need to do that, choose the processor and the development tool. So the software selection is the first. You need to choose the right compiler that suits to your design and that suits to your customer requirements. Then you need to choose whether your project needs a real-time operating systems or just a simple program. Once you've chosen that, then you can start to develop. And first thing to develop is to start with the networking protocols. So does your project needs major networking devices to convey your coding to the end users? If not, then just deal with one Ethernet cable connection from one end to the other and so forth like that. So you'll be learning a lot about networking protocols, and that will start your development process in the software side. And then the Java support. Java support again, that will be in bigger companies, that will be a major division. There will be plenty of engineers who do nothing but Java code written. There is also a lot of involvement that's connected with embedded development when in terms of databases and images and clips. So Java support really helps. So that will happen on in parallel with the software development. And then the graphic support, the look and feel, how you would like your the product to be reached out, how they would like to interact with that product. So that's where the graphic support comes. And that in the software side of it, they will give you a demo session where it's a look and feel. And then there is the project and code management will be in there, who will be on the back of all this, who will be controlling and managing the cost, the budget, and the timeline for each and every individual component or the sections. And that even it's a whole dedicated team who will concentrate and give inputs to the team. Then once that's all covered, then you have to start to simulate to see your written code and sits with the customer requirements, whether you're covering the functionality of it. So that's, you do that in the RTO simulation. That's in the software side. So let's move on to the hardware. First, you have to select the hardware selection, the semiconductor, what processor you need, your customer need. So as a design engineer, you have to come up with your search and suggest that to your senior engineers or to the client. So you select with that. For example, this course we're going to learn about STM32F411. Likewise, there is PIC microcontrollers, other ARM microcontrollers, 8051. There are plenty of out there, so you have to choose. And then once you've chosen that, then you need to do the hardware coverage. How are you going to link that to your hardware to the software? So what are all the necessary packages and the production tool that comes with that? Then the next step is the board bring up. All up to now is the selection, the development. Now you actually putting your ideas, your written or drew diagrams into a tool, and to bring the schematics and layout into the board bring up. Once that's done, then you're going to concentrate on the board diagnostics and manufacturing testing, so the prototype testing. After the initial test board is done, you're going to do all the functionality checks. So that's what in that section is. And then in the hardware side, you're going to do the source level debugging. So up to that stage, what functions are covered according to the output, according to customer requirements. So that's done in source level debugging. So once these two, they will run in parallel in the industry. So they'll have dedicated software teams and the hardware team. And then this is the time now you're going to integrate both software and hardware. And on the software side, you're going to do rapid prototyping. So which is you're going to test a lot of times about the functionality coverage, and you're going to do a real-time data visualization, which you're going to see the real-time data, how your input is coming, how your output is going. And the next one is the testing and tuning. There could be a memory leakage detection. Sometimes the memory could overflow because of data conversion, and you're going to check with that. And then the CPU profiling, how fast your data is processing. Does it needs a booster to speed up the process? So you need to know that. In the hardware side of it, when you integrate, you need to do a real-time system analysis and the debugging. There are a lot of simulation tools out there where you can just fire your program into that chip in that program, and that will do the real-time analysis. You can see that's where the logic analyzer will come in handy for your design. So you can check the waveforms and see how it behaves from your input to the output. And then the testing and tuning is your execution tracing. So you need to keep tracing from all the customer requirements and the functions to what stage you have covered. If not, go back to the team and say, we haven't covered this, so please start covering that particular point, like 2.9.3 or something, whatever the case may be. So that's the execution tracing. And then in the hardware testing and tuning is the code coverage analysis. How far are you functionally covered for that product to be moved on to the production stage? So once all this is done, then we move on to what's called deployment. On the software side, it's called a post-mortem debug. On the hardware side, it's called in-field debugging. What is a post-mortem debug? For instance, you completed the product and then you sold that or given to the client, and the client has that product, and occasionally that product or system may crash due to unavoidable reasons, like the internet may be slow, or there may be a network issue and the system could crash. So that's what we involve in it, and we do a post-mortem debug where you can do that over the air, like send a package to your client and the client can install in it and do all sorts of things. And that's post-mortem debug is all about. In-field debugging is hardware check at client's premises or wherever they are. You go and sit with the client and then you come up with all the testing for what they required and see how it behaves in the real field. And you would take plenty of inputs from these two sections and then you bring back to your team, and that's how the development cycle develops, and then they come up with version 2, version 3, etc. So this is how the total embedded development life cycle operates, and I'm sure by end of your career you would be having your hands on in all of those. But I'm sure with this fast tracking learning out there, within no time you would be able to mm, get your hands on in all of these individual sections. Okay, just to recap of what we learned today, we learned about what is an embedded systems and the classification of the embedded systems and what are all the available processors and controllers we use in the embedded system, what are all the programming languages that we use to design your embedded systems, and the dominating manufacturing companies who manufacture those CPUs, and which companies dominate in designing their processor cores, and some applications where the embedded system design can use, and how you can convert your own ideas or your customer ideas to a prototype, and then elaborately about the embedded development lifecycle. I'm sure if you have any doubts, go back to the video and watch it again. And still, if you have more doubts, please go to the Facebook group, which I will show in the next slides, and you can input that in there, and I would be able to assist you to clear your doubts. As I said earlier, it's both soft skills and the mindset skills. So this is where the today's session is for the mindset preparation. Please have a definite goal in your life in general. Without a goal, it's like a deadline. It's nothing. Like it's similar to you're chasing a light at the end of a dark tunnel. You know the light is out there somewhere, but if you don't know if it is, say, a kilometer or 2 kilometers, all that you can do is just keep running and you won't be able to go there. So, yeah, likewise, have a dedicated goal, a definite goal, and then I also given you a goal card where you can write your own goals and see that, visualize that every day so that you can tune yourself and approach and get through to that to make it successful. So that will be the day one mindset preparation for you. And I'm going to involve you with a little bit of mindset involvement. So these are all the things that I would like you to follow and through. Write down your top 10 goals and write down your top 10 ideas to achieve those 10 goals. So you get each point. And then I love fitness and I love to exercise and do my workouts. I still play a lot of sports myself, so I would like you to do the same, and that refreshes you physically and mentally if you want to learn a lot of things, and that really helps. At least spend 30 minutes for an exercise, or if you'd like to go to gym, then go and do a workout. If not, then if you'd like to be a walker, do about 3,000 to 7,000 steps a day, and that will give you 2 points. And then please dedicate at least 15 minutes to meditate or pray. If you're a religious person, please go to a temple, church, or mosque, or Jewish mosque, or anywhere, and just dedicate 15 minutes. Or if you're not a believer in religion, then just close your eyes and meditate for 15 minutes. Just clear off your mind from everything. So you get 2 points for that. And then please dedicate 10 minutes of visualizing of actually you achieved what you written in the previous page about achieving that goal or achieved that goal. So that gives a point. And then please take 10 minutes of focusing on the daily plan activities, like what you're going to do for the rest of the day, or how you're going to set yourself for tomorrow, or how you're going to plan out the next week. So prepare a plan. At least spend 10 minutes to do that. And then the 2 hours of learning and taking down notes from my lecture will give you 2 points. As I said, a little idea can spark into better features, so you get 2 points. Why we have to do this is, if you could please post all of your involvement in the Facebook group that I given you, so that we can motivate each other, and if someone falls behind they would be able to follow this, and that motivates others to follow through. So that's why it's a mindset involvement, and it's a combined activity. So please, let's help each other out, and in the end, I'm sure, I guarantee you, at the end of 30 days you will be a better person from what you are right now. And please put your questions and your doubts into this group when you come in. Post a comment and I will be able to help you to answer all of that. And there is something to give you that's coming up your way. It's a combo internship. And this is a course with the beginner, and you can also purchase intermediate course and advanced course as a bundle combo or on its own. And then further up, we going to present you with all those embedded C programming internship on current course, IoT design and PCB design and Arduino. That's on process. You will be able to hear that from us. But to start off with, you'll get the Cortex M4 beginner, and then you gradually move into learning other things. I do like to make an announcement, if you'd like, please. There is 2 different systems, or if you'd like 2 different memberships, if you like. What I'm going to teach you, I'm going to load all that into YouTube, my channel, for you to learn. And I classify that as a YouTube viewers. What it is if you watch my videos for 28 consecutive classes or 28 days, you will be eligible to get a free certificate. But with YouTube regulations, a video have to be removed after 2 or 3 days, so that video can't live there permanently, so you won't be able to go back to it and learn. So because you can't access to the content, so you have to learn that every day by going into the video. Whereas I advise you and please recommend you to go for the internship. I classify that as the internship professionals. This will give you and acquire you an internship certificate that value a lot when you land into that first job, because they consider this 30 days course as a formal training or formal experience, and that counts a lot. For instance, if you're going to compete with other person who don't have much hands-on experience, you sit on top of the queue, so this will help. So please use A2Digi and IndosLink LMS portal, the learning management system portal, to go through each and every day's session and complete and continue each day, and that will cover you for the attendance for your certificate purpose. And for signing up with our internship, that will give you unlimited access on all the course contents. You would be able to download all the PDF materials and all the related documents with that particular class, and you can watch the videos any number of times, and you'll also hear from our backend team if you need support. So that's the 2 different things out there. And I personally thank you so much for all your time today, and thank you so much for your patience, and I wish you to have a lovely, productive, fruitful day. Please go and enjoy that lovely break from the screen, and I'll see you on day 2. Until then, have a lovely day and enjoy yourself. And this is Arulan Bukarasu. I am signing off on A2Digi's behalf, and I'll see you on day 2. Thank you. Huru for now.